cashiers who sell, packers who pack. And, the question every system eventually has to answer is, where should each of them actually run? Normally, that question leaks right into the code. A queue name appears in a class. A hostname shows up in a config that the domain reads. A retry policy gets written right next to a business rule. And once that happens, moving a component is no longer just a deployment decision. It becomes a code change, complete with a test cycle attached. So this case shows the exact same set of characters deployed in two completely different ways. But the script? It's identical to the letter. A puppet is essentially a character in a program. It's a named who, defined by his verbs, which is what he knows how to do, like sell or pack, and his journal. The journal is the diary of everything he's done, written out as sentences, in order. That pair is his identity. Picture a supermarket. You've got 3 machines, and on each one, there's a cashier with his own packer standing right beside him. When the cashier finishes a sale, he speaks to the packer, and that message never even leaves the machine. There's no network hop, no certificates, nothing to secure, and nothing that can time out. It's literally the cheapest possible conversation. Now, picture the gift wrap counter instead. We have 3 cashiers on 3 machines and 1 shared packer on a machine of his own because he takes his time and he serves everybody. Now, those same messages ride the wire across the network and through a broker. And here's the point of the whole case. The script did not change, not one single letter. The reason is that the script only ever names roles. It basically says, tell the packer. It never says which machine the packer is on. It never names a wire, it never names a broker, and it never mentions a topic. There simply isn't a clause in the language for any of that. So what actually resolves a role to an actual route? It's a small binding table that gets consulted at runtime, and it lives entirely outside the program, kind of the way DNS lives outside the program that opens a connection. In our first floor plan, the table resolves packer to something in the same process. In the second floor plan, it resolves to a broker topic, but the journal reads identically either way, because the wire never actually enters the character's voice. Let's say the packer's machine is getting full and you want him somewhere else. The whole operation is just 2 steps. 1, you cut the box out of one drawing and paste it into another. And 2, you update one entry in the binding table. The message now travels farther, sure, but the script does not change. He's still the exact same packer, with the same verbs and the same journal. Why? Because identity was never the machine. In the first drawing, there are 3 packers. They wear the same uniform and they know the same verbs. They all pack. But they are 3 completely different characters because each one keeps his own journal. It's 3 separate stories. Packer 1 has no idea what Packer 2 wrapped today, and he really doesn't need to. Now compare that with a character declared a stage V2 instead of a performance V2. This is someone who stands on several machines at once. Those replicas also share the same verbs, but they all apply the same journal, and it's worth being really exact about that word. Only one of them ever writes. The others just apply what it wrote, and none of them edits a copy of its own. So that is one character in several places, not several characters. So the rule falls out cleanly. Same verbs plus the same journal equals the same character. Same verbs plus different journals equals different characters. Identity is the verbs and the history. It's never the hardware. Now you might be thinking, come on. In the second drawing, the message crosses a network. Surely something has to change. Timeouts, retries, serialization, error handling. You cannot tell me a local call and a remote call are the same code. And you'd be correct. Something does change, but not in the program. Delivery concerns belong to the transport. Whether to retry, how long to wait, what to do with a message that just can't be delivered. The character's part is totally unchanged because his part was never delivery. His part was speaking. He records that he spoke to a role. What carried it? Well, that's the deployment's business. That is why the exact same sentence, read in the journal, is true in both drawings. We have to be precise here. Same verbs does not mean the same character. This is absolutely the mistake to avoid, and it's a natural one to make because in most systems, 2 components running the same code are just interchangeable replicas. But here, they are not. 3 packers with 3 journals are 3 individuals with 3 completely distinct histories. What makes several replicas into one character is a shared journal, not shared code. Think about what's absent here. There's no host name and no machine name anywhere in the domain language. There's no queue name, no topic, and no broker named in the script. You won't find a retry policy sitting next to a business rule. And most importantly, there's absolutely no code change between the two floor plans. If you ask an architect for a distributed systems diagram, it usually takes days. That's because the diagram is essentially a proposal about infrastructure, and every single box in it implies code that has to be written to match. But here, the relationship runs the other way. You draw the boxes, place the characters, bind the roles, and the system just follows the drawing. The diagram stopped being a document about the system. It became the way you say what the system is.